A quick message from the future. This video is actually a compilation of a few parts of what will be the next video after this one. I just decided they would make the most logical sense in their own separate thing. The main topic and the main goal is optimize Overture and create a new, cleaner architecture that will be compatible with Overture. Now, obviously, I could just apply leg to solve these issues, to solve all these problems. Leg is strictly more powerful than Overture, strictly more expressive. I can do more things with it. But I think there is merit to using a small thing. And the idea is, the first thing I'm going to do, I intend to do right now, hopefully I can create a whole new architecture in the next 20 minutes. I think I want to keep the specification of Overture, make a new architecture that will implement the Overture instruction set, and use that to solve this maze. I think what I'm gonna do is I'm gonna base it on the old Overture, and I'm not gonna call it Overture 2, I'm gonna call it ACT1. I think ACT1 sounds like a, you know, an old school processor name, right? I like it. So yeah, there's a lot to be improved here. What is this? What is that? I don't know. This is, yeah, I think this is for immediate mode. Yeah, this is for immediate load. But okay, so the thing, how this works is we have our ALU, but the ALU is constantly using registers B and C, and it always outputs to where? I think it always outputs to D. Yeah, we have 2 bits of instruction, these ones. They are decoded by this decoder, which this is literally just a decoder. We have 4 opcodes. We have immediate, calculation, copy, condition. And when we're calculating, it enables the ALU over here, yeah. And also it overrides the right pin of register ABCD, of register D. But these two are not actually 2 inputs. Overture does not work on 2 inputs. Overture does not have 2 of these lines as well. So this is really the output line, kind of. While this is just an output selector, and this is an input selector, I believe. Or actually, it's the other way around. Is it? No, this is right. This is the input selector, and this is the output selector. So let's color them using our new color scheme. So we're gonna have blue for input, and we're gonna have green for output. So this is gonna be the same as leg, right? Like this, and also this is that. This is also the output, and so immediately, one thing I want to do is I want to swap these, just so we don't have this intersection up here. I'll do that. Okay, it's a bit weird that the output is to the left of the input, but whatever. I think the colors are clear enough. So next minor improvement, I'm just trying to take it incrementally. Let's make IO register. So let's get rid of this here horrible situation. So I'll be right back with this. Okay, something along these lines. Yeah, it's just, we don't have anything fancy, so they are literally just connected to the same thing. Okay, what next? What next? So another simple change I could make is these decoders, and also I don't like this thing. This is literally just a decoder as well. This is a 2-bit decoder. So I think what I would want is I want to use these 2 bits manually and have a component that has 2 bits as the input, which I literally have. Yeah, I'm gonna just do that right now. Okay. But you know what? I don't like this knot here. It's actually really weird. Why do I need a knot? So when this is... What? So the default... Yeah, the default behavior... Actually, no, it's always... Unless... Aha, yeah, so I had... Yeah, I had... In the instruction decoder, what I have is copy mode. So I literally need these to be enabled when copy mode is on. Yeah, that's awkward. Okay, how do I don't want these, I don't think. Or do I? No, I literally want these. Except I'm not using one of the things. Okay, give me a moment to think about this knot. Yeah, no, I do not want these. I think I want them switched. This is gonna be slightly expensive. However, what that will allow me to do is I won't need these ores. I will be able to just connect the thing here, right? The way in a very similar way to what I do in leg, which, by the way, there is a bug in leg right now, which I forgot to address. I will address it later, and I will address it for Act 1 right now, but I want to put the leg clarification in the leg fix in clarifications corner, so that will come later. But yeah, I think I want switched decoders. Although, actually, no, I don't need... Yeah, no, wait, I don't actually need them switched. I only need one thing switched. So yeah, in order to have a free ore over here, what I can do is I can create a custom component, which I will call... I don't know what I'll call it, but effectively it will be a one-way wire. One way. Something like this. One way. And what I'm thinking is a 1-bit input and a 1-bit switched output. Do I have... Yeah, 1-bit switched output. Just like this. And all this is gonna be free, is this thing, right? I'm gonna just plop an off switch for area, for size, right? And what this is I can power this thing on, and then it influences its output. Oh, it's not free, right? It's 1 because the output costs 1. But when this is on, it influences its output. But when it's off, first of all, it doesn't influence the output at all. And second, the signal does not get back propagated. So if this is on, then this one-way switch is not gonna output a signal here. So that will protect this line from this line being on. And what I do now is I get my one-way switch and I plop it here, right? It's still a short circuit. Why is this a short circuit? Don't want the ore. Okay, this is a short circuit for some reason. I don't exactly understand. Oh, that's why. Yes, I do. Okay, I do want the decoder to be switched as well in order for this to work. But it's an expensive solution. It's an expensive solution just for vanity reasons. If I don't have... Yeah. I don't know. Maybe I do want to keep the ore. I'm not sure. Okay, give me a moment here. You know what? Kind of in the mood for some experimentation. Let's see. For unconventional layouts and things. So Act 1, I made this. This is a 3-bit decoder that is switched. And these are 3 of its inputs. And those are its outputs. And you can see that it is completely flat. So what I can do, let me free up some space. I can remove this. I can plop this instead. And then, like so, and like so. Now we have this decoder, and it is completely free and open to new inputs, right, from the top. And this means I can have these ORs removed completely, and I can have, I believe, unless I'm wrong, of course, I can have my 2 one-way things over here and over here. This is going to be for purple, and this is going to be for red. Right, so now I don't need this, I don't need this, I don't need this. I don't need any of this. These are now instances of the same thing. I don't really need to replace the other decoder, although I maybe want to just for symmetry. But for now, let's just keep it this way and let it breathe again. Overall, it's just it's all very cramped. I don't like that. Let's move everything to the side a bit. And then even more space. Stop with this random wire. Okay, so this is already looking a bit cleaner. But I do still have these 2 things, the red and the purple, going to the ALU and to the immediate mode selector. But before I get to them, I think I do want a customized instruction decoder with this knot. Because this I have already effectively put in the... Come on, I want nice color. No, I want nice color, please. No. I want the color to be... Yes. So, yeah, this decoder is already customized specifically for ACT1. And in fact, I made a new directory in my component factory for ACT1. So these will be ACT1 specific things. And I think I want an ACT1 specific decoder, so I'll be right back. So here we have our specialized mode decoder, which is just a 3-bit decoder with a knot inside it. So now we have these modes: immediate, calculation, copy, condition. So that's that. This is already getting a bit better. Let's let the left side breathe a bit. Okay, so next up, I want my cond and ALU on this side. Or actually, for leg, I have been considering putting everything on one line. So you know how in leg I actually have like a thing running down here and then up. I've been thinking I don't actually need that. I could put everything here, but then, would I want to flip this then? You know, put this here as well, and the program. Let me think for a moment. Yeah, you know what? Why not? I just said I'm in the mood for experimentation with layouts, so I'm gonna move all of this stuff on this side. And I'm gonna have a main bus right here in the middle. And then I'll have my registers on the left and some other stuff on the right. And that will involve moving this and flipping it. So, be right back. Yeah. This is awkward. This is weird. This is not great, but I'm gonna plow ahead. So yeah, the same thing, except now this is majorly broken, in multiple ways, but I will fix it. So yeah, we have our registers. This is the register block. It has some specialized reasoning based on the mode, based on my opcodes. But now what I need to do is I need to figure out the ALU, the conditional block, and everything else. So what we have, so right now, I have my two input-output, the common colors, light blue, dark blue for input-output, or input 1, input 2 for the ALU, and then output goes back into the green line. So it's classic that way. But we also have jumps to address from register whatever, from register 1, from register A. That's this line. And we also have conditions based on register 4, A, B, C, D, E, based on register E. And that's also on the bus. I cannot say I love this, but it is what it is. And yeah, we have our instruction, which is white, and we have our thing, which actually maybe I want instruction yellow. Yeah, I've been using yellow for control flow. So that's something, but right now, immediate mode doesn't work because I don't have a way to immediately load a number from the instruction to green. And also the ALU is not switched, so we're constantly performing the operation. But the way I have it in leg is that the ALU has a gray pin for output. So I'm gonna do that right now, actually. Be right back. Yeah, this is a bit weird, a bit unoptimal, but yeah, this is the ALU now. I implemented the new, more sophisticated add subtract thing with the not and the or, and you may remember this. So this is going to be much more efficient now. And I replaced a mux board. This was a mux board with a decoder. But the problem is this part, which is kind of necessary to decide whether we are in arithmetic mode or not, in comp mode, computation mode. This is duplicate, actually. This is duplicate to what we have here. So essentially, what I'm forced to do, unless I want to pipe this all the way back to the ALU, I am forced to infer the mode twice. I infer it here separately, and I infer it here separately. And it's kind of what I do in leg, except in leg it's free. So if we take a look at leg, no, not like right here, right in acond, I use bit 32 and bit 8 separately to decide what I'm doing. In AALU, I use bit 32 right here to decide what's happening. And the difference is, here it's basically free. And again, bit 32 gets used here as well. But because it's a single bit and it's a Boolean value, I do not need to separately decode this. And it is, like I've already said 3 times, free. While in Act 1, because we only have 2 bits encoding 4 modes, this means that these 2 bits need to be decoded always. So if I want to decode them in the ALU, I need this kind of contraption. Which is fine. I still think this is much cheaper than what I had. Unfortunately, I forgot and changed this destructively, so I lost my original ALU, but this is it. So yeah, unfortunately, that's weird. That's a weirdness, but that's kind of at the core of the architecture itself. And now what we need to do is I still need to figure out immediate mode, which also, you know, yeah, perhaps I want a separate mode decoder You know, perhaps I want it like up here somewhere. And then these 4 lines I can use. Right, and then I wouldn't want this one. That's actually an interesting suggestion. And then I would pipe it into the ALU and everywhere. But that would create a huge bus. Okay, today is yes day. Today is ambitious layout day, so I'm gonna make a huge bus. Be right back. So something along these lines. I have an instruction line, and I have my actual computed values and values line. So now I can go completely insane, and I can add a 1-bit input, which is gonna be enable. I still need the instruction, but the enable thing will now be enabling, because I need the instruction to infer opcode for these 3 bits. Yeah, I'm really going over the top. I know I am. But yeah, so now arithmetic mode is which color? I use this color for arithmetic mode, so I can now do something like this. Wait, what? No, that's not the color. What is arithmetic mode? No, I used duplicate colors. Oh no. This is bad. What's arithmetic mode gonna be? I'm running out of colors. Oh no. Oh, I have completely run out of colors. Okay, white it is. White is arithmetic mode. So white arithmetic. And now we have arithmetic. And well, yeah, so this... Wait. Problem is, this wire is both computed by arithmetic and used in condition. So it's double purpose, which is, I mean, convenient at times, but does not necessarily allow me to color it in any nice way. Yeah, and this is also used in... Wait, is it? Okay, be right back. Yeah, no, this is correct. It's just so annoyingly weird. It's a lot of these registers are overloaded. These 2 are completely free, but this is both a register I save an immediate value to, and it's also the register from which I can overwrite the counter. These 2 are registers that are arguments for the ALU, and this one is both the output of the ALU and the condition. So the argument of the condition. And there's just so much stuff here. But oh well, I'm gonna plow ahead. And I think I'm gonna streamline my condition block, except I don't know how. Do I want to merge condition and the switch and the counter, or what? Okay, give me a moment. Oh, it's this thing. This is not very maintainable. I don't remember how... which conditions these are, but that's not really the problem for me. So yeah, I was about to consider whether I should merge these things. Okay, squished it a bit, and I added the enable pin the same way we did for the ALU. Except, yeah, I now put stuff in the new directory. So we have the ALU and we have the ACT1 cond block, which is this. And now my conditional mode is going to be what? Conditional. Okay, gray for clock. Makes sense. Right, and now I don't need this switch. And I can directly connect my condition to the counter. Right? Something along these lines. Control flow. Right? And the counter is gonna stay outside. But my general setup is to have things going down as the output. So that's gonna be our output, no? Yeah. Wait, is this it? Wait, am I done? I think I might be done, actually. What else? Oh, I'm still missing immediate mode, which is going to just be a switch. So give me an 8-bit switch over here. I feel like immediate mode goes first. Actually, yeah, so we have the order of these things is immediate mode first, second is arithmetic, and this is last, actually. So, why is that weird? Don't be weird, please. Yeah, so first, second, third. Third is gonna be registers. Copy mode, which, I mean, I would kind of put this all the way down below the registers. Huh, that would be an interesting thing. Yeah, you know what? I only just realized that these outputs, so, you know, going down, back, and to the main bus, down, back, into the main bus, these kinds of things, which are common, is actually, oops, come on, give me, give me something. Switch schematic, leg 16, yeah, yeah. This going down, back, and up. So this is a whole thing. And this is kind of a register operation mode. Although, yeah, it's not exactly, but kind of. Okay, come on, get back to Act 1. Yeah, so all I do is I just have an immediate mode right here, which just takes the instruction and plops it as the output. And that's it. This is it. Right? Yeah. I think this might be a functional Act 1. Let's try. Is the robot... No, the robot is broken. Yeah, I forgot something. I must have forgotten something, but I still need to figure out what it was. Okay, the cond is not connected. No, cond is connected to the instruction. So this is the mode. Alright, I'll figure it out and I'll be right back. It was a minor stupid wiring mistake. I had my mode decided by the first 2 bits as opposed to the last 2 bits. No problem. Found it fairly quickly, and I think this should work now. Yes. Wait. I want to see my score. I haven't yet recompleted this level. So the score for the maze was... Do I try to remember all this? Nah, 6.8k. Let's see how we do now. It's not actually gonna be much more interesting. Yeah, all that really changes is the gate scores and the layout. The layout is much nicer now. But yeah, the program is of course exactly the same. So the tick score should be the same. Excuse me, everything crashed. Everything froze. Wow. 4.5. Okay. That's interesting. I seem to have saved 1,000 score. Even more. 1.5K. Where? It's the same thing. Is it delay? It might be delay actually. That's interesting. It might be based on delay. But yeah, this is interesting. Do I want my program on the right as well? I don't know. It doesn't really matter. So here's my Act 1. This is an Overture compatible thing. Yeah, IO is not IO. IO is different things. I'm just wondering what else could I change here? What could I improve or update? Give me a moment. Right, I think these registers are junk. I think I want fancy new registers. So yeah, these are using the default register, and that's not cool. That's not cool. Yeah, I'm gonna make a cool new register. Something along these lines. So fancy new registers, like style, pretty simple, the exact same thing. And I thought, while we're on the topic of cool layouts or experimental layouts, I might as well make it compact. Move the program down, so the program is really now part of the thing. It has an input, which is the clock, and it has an output, which is the instruction. So yeah, that's that. I did just realize that I was very much confused about what these are. Overture and Act 1 don't really have a clear separation of what's input and what's output. Like there is an input and an output in move mode, in copy mode, but it's a pain. So I had these things colored backwards basically. I recolored them. But yeah, I think that's about it for Act 1. It should work. Yeah, it still works. You know what? While we're on the topic of cleaning up Turing complete architectures, I think I want to take a look at lag. And this doesn't require any actual optimizations, but I don't expect to be adding any more functionality to it. I might want to do something else in the future, but that would probably even be a different architecture. So for now, I think this is the finished version of leg, perhaps up to some tweaks. And I want to just make this more compact, and I think I want to apply the principle where I have the main bus and everything is to the right of it, and this thing is a component, and the program is also a component. So I'll just do that off camera, but I wanted to show and to say that I was doing it, and I wanted to show the result. So I'll be right back with this done. This did make leg very vertical, because I would have a program right down here somewhere. But, I guess. It is kind of annoying that sometimes I like to look at my hardware and I will need to scroll all the way back to the program to actually edit assembly, and then back to the registers to look at them. But yeah, we still do have a couple of, actually quite a few. How many is this? 6. We still have 6 unused register slots, which I could easily add, but for now I don't have a need for them, so I just mark them in gray. This is gonna be easily extensible. I can just, you know, do this. But yeah, that's probably gonna be my new leg. It's exactly the same, just with a slightly different layout. Oh, and these wires are now green again. I still don't understand why wires sometimes turn green. It's supposed to have something to do with the size of the wire, the width of it. But these are 8-bit wires, and I expect 8-bit wires to be blue, but... well... apparently not. I don't know. So yeah. That's the new leg.